Hello, good evening. By the way, the name of the talk is not OOP is dead, as that's not going to be the argument tonight. That was a working title, and it actually was a question. My name is Danielle. I've been for the last 3 years or so a functional Scala programmer, but this is not going to be the subject of the talk. There might just be a couple of mentions, but it really is not. I'm going to talk about OOP. And why I've decided to give this talk I've been thinking about it for a few years now, actually. I keep hearing people saying that OOP is dead, and a lot of people are looking elsewhere for the solution to their problems. And I hear a lot of non-arguments around some very intellectually not particularly sharp arguments about why this is so. Things like, well, it was good enough for the 90s, but it's time to move on, or the world has changed, so we shouldn't go to extreme, the virtues in the middle, and stuff like that. I think we're all clever enough that we can try to be a bit more specific than that. And also, we shouldn't fall for selective demonstrations, which you can readily find online, that would like to show you that for some purposes one thing is vastly superior to another. That doesn't really prove very much. It's a very relevant argument. If you search online for OOP is dead, you find loads of talks, essays. It can also be a very emotional argument, because when someone attacks what we've been studying for a lot of our professional lives, we feel personally attacked. Nevertheless, there's people that say OOP we should move past it. And I'm wondering, if this is true, then has it simply been overtaken by events, or was it flawed from the beginning? My point is going to be, I'm going to try to show that, on the contrary, I think OOP is as relevant as always. And in fact, it's an almost unavoidable approach in certain situations, because it's a natural way of thinking, and it answers some of our natural thought patterns. But I'm going to start with a statement that I'm assuming most people will agree with, which is doing OOP is not the same thing as using OOP language. Can we all agree with that? I'm going to go ahead and make another two statements, not my statements, other people's statements, but you might agree with these less, such as Java killed OOP, or Java was a marketing scam in calling itself OOP. If you don't see how these things could have been, where this idea could have come from, bear with me, and I hope that you will see it during the course of the talk. If not, anything that you don't get, please ask questions at the end. So is OOP a dead thing, a finished thing? Should we give up on it? So let's start with some criticism first off for OOP. You get the argument very often that with OOP, with large systems, static analysis, static thinking about your program becomes almost impossible. It's impossible to tell what's actually going to happen until you run it, simply because the interaction patterns are too complicated. And so massive test suites are required just to be able to guarantee anything. Very often, through inheritance abuse, you can end in a situation that's even worse, where it's even harder to follow what's going on. And here comes one of my favorite quotes, that a polymorphic function call is a hypergalactic go-to, which comes from a fairly well-known paper. we find it hard to reason statically about it. Also, other critics say that OP promised us a very neat and tidy modeling of the real world, and told us we wouldn't need global variables anymore, we wouldn't need utility code anymore. All those things were to be abhorred. But in fact, if you look at the patterns of interaction between objects in average application, you can see that sometimes the certain objects are no different from being global variables, and certain codes that we sort of shoehorned into certain objects that we sort of concocted ad hoc is nothing more than utility code. So shouldn't we just be honest about it? Also, OP told us that through inheritance we'll be able to neatly model the real world in a hierarchical way. We've all heard in school probably the example of the abstract class animal, and then you have mammal extends animal, and then you have a dog. But in actual practice, and I think we've all been there, you end up with things that end up fairly far removed from the real world, and in fact have nothing to do with them, and it's impossible to reason about them in your head as if they were something that you would relate to yourself. Then another criticism is that inheritance always turns into an unmaintainable mess, that we're told to use composition instead of inheritance, but that's really, we're told that just because it's the only way to sort of kettle the problem somehow. It's endemic, it's unavoidable, and it all stems from the fact that, OP will specify data and behavior together, and their being together impedes abstraction to the level that we would like it to go. Again, not my arguments, but you can easily find them online. And also about encapsulation. Is it really a good idea to have all that stay hidden inside objects? Wouldn't it be better to just have the object centralized instead, so we can manage it somehow instead of having objects manage it? So a lot of arguments, and finally they come and say, well, there's vast amounts of literature out there about design patterns, about object-oriented strategies and design patterns, but could it be that all these patterns are there, that we need it just because OP itself encourages bad design to start with? Is it just a patch on a dysfunctional and flawed central idea? So has all these been waste? And they go and say in one famous essay, please spare a thought for poor Uncle Bob and his friends that has spent so much of their career writing about what they see as trivial things, such as, we should be doing injection via constructor or via setters, things that are fairly trivial when they could have focused on something more interesting. In a way, this famous essay claims that it's been a waste of the brilliant mind. So in closing, many criticisms of object-oriented programming end up saying something along this line, that OP has no unique strength, that the strength that it does have are not really exclusive to OP. They can be replicated in other approaches if you do things properly, but it has this one fatal weakness. With specified data, jointly with behavior, you can't really get the level of abstraction that you would like. Okay, so perhaps, if you let it sink in for a while, it's actually quite scary if this all were, if they all had a point, and I think partially they have a point, but that's the argument. We've got to hear a counter-argument. So first of all, what exactly is OP? It's one of those concepts that not many people have a ready definition of in their mind. Is it perhaps about static typing? Well, not really, because we can all think of another language that is statically typed and is not OP, or probably more than one example. Not about dynamic typing either. It's not even about having classes, because you can do OP without classes, as many JavaScript people, for example, know. It's not necessarily about inheritance either, because you can achieve inheritance-like patterns in other ways, in other languages. And it's not even about encapsulation, because encapsulation is more about taking care while you write your code than doing OOP. And most importantly, OOP is not even the sum of all things. It's not the feature set that we have in Java, for example. That's not even a good enough definition. I would argue, really, if we have to say something, that OOP, if it is to serve any purpose, needs to be more of a way of thinking than anything else. And on this note, I'd like to take another step backwards and think about what exactly is the point of programming, of any programming paradigm. Well, obviously, is to have a working program, of course, but a close number two, I think, and I agree with the people with this opinion, is that the goal of any paradigm or approach is to ensure that the code stays maintainable after you've written it. Probably you could write a working system as a sort of one-shot with any language, but if you can't maintain it and evolve it, it's worthless. So it's all about maintenance. But we can all agree that in many systems that we've worked on personally, we didn't have this. Maintenance seems very difficult. So what was the missing ingredient there? And now I would like to go on a couple of two different tangents, different streams of thought to try to explore this a little bit. Again, some of these arguments, most of these arguments, I'm just channeling other people as I'm saying them. A lot of them I agree with, but try to take this as a review of existing, opinions and literature more than a prescription from me. So obviously, you have a programming language, which in the final analysis is just a tool to express a design. If your decomposition of your problem is flawed, then you can't expect the programming language to solve that for you. And another quote, which I think is by David West, is that OOP only has value if it helps you think about the design differently, if it encourages you to decompose your problem domain in a different way. When you try to model a complicated problem domain, you will have complexity because the problem domain is complex, and the complexity doesn't just go away. Using one approach over another can shift it around a little bit. Perhaps you can have simple data types, but complicated algorithms, or you can have simple interactions, but complicated state, or so on. You can, as a rule, and it makes sense to me, that you can only shift the complexity around rather than completely eliminate it. The difference is that as people, we are very good at understanding complexity when it's presented to us as complexity of the real world. We live a complex real world daily, but we seem to be able to instinctively understand it. So certain theorists argue that this is what you should do. You should try to model your domain as closely as possible and play OOP, play to the strengths of OOP, because that's what it was conceived to do, so that's what you should try to do. You shouldn't try to stray from the metaphors of the problem domain unless you absolutely have to, at the point where you have to. And obviously, when programming, you have to translate reality into something. That's another quote, more or less direct. If you're trying to translate to something that is not something that you can naturally process as a person, then you need some sort of scaffolding to help you understand it. It's better if you can model reality with something that allows you to model reality more closely. So this sounds like an advert for DDD, or the domain-driven development, and in a sense it is. So is the problem simply that we're not doing DDD to enough? I think that may well be one of the problems if we're trying to stay close to a pure object paradigm, but it's also the matter that you need the right tool in order to decompose your domain. If you have a problem and you try to decompose it by cutting it across the grain, you're going to have a lot of a harder time that way than if you try to find some more natural way of decomposing. And again, West and his friends argue that we have been obsessing too much about decomposing stuff based on the data attributes rather than based on their behavior. You're not supposed to think in terms of a machine, in terms of database. You should think of object in terms of what they can do for you, what service they can do for you, and data as a secondary thing to help you fulfill those responsibilities. A couple of interesting examples that he gives is the example of a cat versus a tiger. If you model the two things based on the data attributes, then you will say, well, the cat weighs 10 pounds and the tiger weighs 200. Well, one is black and the other is striped. But more interesting to you as a human is the fact that the tiger can eat you, while the cat can't. So this is something that you should probably be more interested in. Another interesting idea, which is a little bit more out there probably, is that he claimed that racism is the fruit of a flawed decomposition on mankind based on data attributes rather than behavioral responsibilities, which it's a bit of a risky metaphor, but it makes sense, like based on attributes rather than what they're able to do. Now, and also modeling in terms of data tends to very low-level thinking. It leads you more easily to mutable state, to abuse of getters and setters, and other things that we probably shouldn't use as much as we do. I'm going to slightly go on we've covered this. On a slide detail talking about state. A lot of people, state is the most common straw man when you talk about OO. A lot of people say state is to be avoided, which I think is a valid point, and say, well, since OOP is all about state, then OOP is to be avoided. So first of all, I think there were many people who realized straight off the bat when they started to put together this OOP that state was not a good thing, and many more are realizing it now. There is no reason why you can't do object-oriented programming while still insisting on immutability. And even when you need to have some sort of states, there are other ways of managing it. For example, instead of having state aside your objects, another possible solution that is proposed is that of having an architecture that allows you to broadcast your state change events to whoever is interested, so that the rest of the system can adjust to this new situation, so that they don't have to worry about what your state is in the moment that they actually interact with you. And if this is starting to remind you of things like functional reactive programming or perhaps event sourcing, then it's not entirely an accident, because a lot of these ideas were actually in the pool original ideas that were floating about when object orientation was starting to develop, but didn't quite make it in the first cut, so to speak, of OO languages such as Java. Another interesting fact is that well-designed objects have very little interest. Instead, it is possible to do it this way. That's another direct quote, I think, from West. Another interesting thing is one of the proposed names for object-oriented programming was actually message-oriented programming. And in fact, some people expressed regret that it didn't stick with that name because it would have been more descriptive. But and this is fairly well known, but another name that perhaps might have become the official name by admission of one of the people involved, is actually dataless programming. So having objects as non-data, object as entities that you can request results from without worrying about the data they contain. So, and there's some interesting, really old school paper covering these ideas for the first time from the 60s that they're very, very, very interesting to read because they, although in their own limited way for the nature of the problem we were solving at the time, they advocate for things that only came out much later. Some of them are only they're only becoming popular now. So in fact, the more based on the ideas of these object purists, the more data we see, the further we are from OOP. I don't know how controversial this statement is, but let's leave that for later. Of course, some people work with the opposite approach as well. They do the database design up front, and then they take their tables and they turn them into objects, and that's how they get their objects. And I don't doubt that for some people that works, and for some domains that works, but I think it's a bit of a stretch to call that OOP. So as a summary for this section, I say, like, if we are trying to do proper object orientation rather than simply using an OOP language, we should try to play to its strength, doing something akin to DDD or BDD. And remember that it doesn't make a whole lot of sense if you model your stuff based on data rather than behavior, at least in this vision of the world. Secondly, I would like to go on a different tangent and talking about how we think about control in functional programming. I think if we go on a historical note, when Java and C++ came along, these languages came at a time where they were purporting to replace procedural programming, and they came at a period of transition. So in the original version, in the original cut, if you will, of these languages, they still retained a lot of procedural features that were there in order to aid in this transition and to attract and help old school people coming from the world of procedural programming. We were perhaps supposed to have left these procedural crutches behind after a few years, but in a sense we never did. We're still using and relying on them, and our doing so, it is argued by some people, that has stopped us from being purely object-oriented and sent us down a path where we complicated our lives more than necessary. When I talk about procedural crutches, I'm talking about things such as getters and setters themselves, mutability, and static methods. All of these things were supposed to help someone who wasn't familiar with OOP, but in quoting a speaker who's been one of the sources of my talk, they murder OOP right from the start. So the important things to think about are actually how the objects communicate, the fact that objects have individual responsibilities, and the fact that objects should respect other objects. We should be respectful of our objects and trust them. We very much retain a command and control approach where we tend to take the objectness out of an object and just access the data it contains and work with it ourselves. And we tend to think of ourselves as the main mover of this universe that we create in our program by animating our object, by sending our active thread into them. Well, in fact, in this book, it suggested that we try to go on a more metaphysical approach and think that we just define our universe, we define the object and the script between them, but then we let this metaphysical life force give life to the object, and then they work independently. It's a different way of seeing things, and it implies that our objects are something more like what we now know as actors, and that's not an accident either. The idea of actors is coming out again now, it's becoming popular. But it could be argued that Java should have been like that, or many of the early OOP languages could have been like that right from the start by default. And you can probably think about the language where it is like this by default. The other thing to think about is microservices. Microservices is something that's becoming very popular right now as an architectural pattern. And in a sense, microservices are in fact objects, but designed more strictly and arguably better, because you actually have this you are forced to be nice to an object. In Java, you can simply take an object's content directly by reference through a setter or something like that, and then work with it. So if for example, if you're trying to calculate the total of an account, you can just grab the whole book of transactions from inside the object and sum it yourself. But would you do the same thing if you had to ask a microservice? Would you ask it to send you the whole book of transactions over the network? Probably not. You'd be more inclined to give it the responsibility to calculate that thing for you. So you see that when you have the network in the way and communication has a cost, then we are forced to ask politely and to wait for an answer rather than treat an object passively. It is argued that you should have the same strategy, whichever object you design, even locally. You should have the same ideas in mind. Other things I should call echoes of OOP. We already mentioned the actor paradigm and microservices. Other things that sort of were floating about but didn't quite make it initially, but coming now to the surface are things like message queuing architecture, and on the database front, the increasing popularity of NoSQL database, where you tend to store your data as more structured, more organic objects rather than just data. Now, another point to touch upon is that of determinism. And it's, in fact, something that we need to make up our minds in order to figure out where we need to go next. So the question is, do we believe that any given programming problem at any scale can be solved feasibly through a purely deterministic approach, by a purely formal waterproof approach, or not? Or do we argue that we need to accept some degree of chaos? This is not something that I have made up my mind on myself, but it seems that certainly formal thinking, trying to solve a problem formally and in a sort of fully explored way, is certainly possible at some scale, but it is argued again by some of these purists that determinism doesn't actually scale all that well. When you get to a certain level of scale, you don't have the luxury anymore. Your complexity explodes if you try to be completely deterministic. And instead, you should, like the real world, accept that you're going to be a little bit organic, a little bit almost biological-like. There's going to be a little bit of chaos, and it's not going to be entirely predictable. There might be failures, and the best thing you can do is try to live with them. And the parallel is made, for example, between the AI done with Prolog, where it's entirely formal but fairly limited in what it can do, and perhaps AI done with a neural network, where you can't really reason about a neural network all that well, and it is fuzzy, but it can do things that probably Prolog will never be able to do. Another parallel that the author comes up with is ant colonies, which are based on simple rules, non-deterministic, but they scale to huge sizes, and they have emergent behavior, versus perhaps some other example of a large-scale system that, where you try to run it deterministically, doesn't work so well, which we could take as an example, the central planning of the economy in communist countries. So it might be that we need to accept a small amount of determinism, at least at some extreme levels of scales of complexity. Perhaps I haven't made up my mind myself. Well, at a small scale, we can continue to do what we're doing. The good thing is that we're already dealing with non-determinism in various ways, because when we're doing microservices, we have to deal with network failures, latency, and various other failures. So we're already doing it. So we were sort of, in a way, it's not an entirely new thing to do. And as I said, it might be appropriate at different scales to take different approaches. If you have a complicated problem but you're zoomed in far enough to one specific detail, you can probably think and come up with a form of solutions that sort of encompasses all you need to do, while where you get to the point of services, with a more global system architecture, and services and other things at a higher level, you might be forced to switch at a more chaotic, organic level, non-deterministic approach. I think over the years, thanks to better tooling, better programming languages, and all the research that we've done, I think that the switch point at which we have to make this switch in mentality is creeping up slowly. But I think for a project of a complexity above a certain given amount, you are forced to switch into the into sort of object-based thinking. You need to actually ask your own mind to work for you, your own intuitive understanding of things to work for you, rather than rely on completely formal analysis. And this is one of the main points of West and the others. So, yeah, again, taking home from this section is that OP is about, we should try to really relax about the idea of control a little bit, and admit that it is not something that we can realistically keep all the time, and this is something that is useful in modern problems as well, when you go and distribute it. So to wrap up, do we have some good reasons to ditch OOP? Well, we're not going to ditch something just because something new comes along. The fact that it's new is not good enough. I mean, obviously, I shouldn't even have to say it. There's another argument that says, well, in the future, all programming languages will be polyglots. They will speak different paradigms. You can do functional, object-oriented, reactive, and whatnot, all in one. They will all speak all these different languages, and you just take what you need. And while I agree that this is probably convenient, I think this argument is, what I call the smorgasbord argument, is overly pragmatic and utilitarian and slightly intellectually lazy. I think that if you do that, we could fragment the user base of a language. Well, everyone does things differently. If you don't have a solid base upon which to base your thinking, you might struggle to actually build on top of it and come up with new patterns. And finally, I'm not sure if it's a very good idea to have, in a way, rootless programmers, rootless people without a central creed who don't know who they are. Might lead to a bit of drifting. And of course, I could also make an argument argumentum ad populum, where I say, well, people vote with their feet. If they live in OOP, then that they vote with their feet and that we shouldn't really try to analyze it too much. Well, yes, but remember that legacy can be very powerful in keeping bad things in power while keeping good things out of power just for trivial reasons such as failures of marketing. I think we shouldn't try to read too much into it. And any reason to keep OOP, as I said, I'm going to need only one. It's a natural way of thinking. It keeps coming up by itself when we reach a certain level of the complexity. So I don't think we should try to fight it. I say, but it's not easy. No, it's not easy. But nothing is easy when the problem you're trying to solve is not easy. And where we take it forward, two paths for evolving OOP. One is to allow OOP. It depends on a large amount whether you believe the non-determinism argument or not. One path, I can see OOP becoming slightly more functional, embracing more the ideas of declarativeness, immutability, and such. On the other side, I can see some people going the other way and taking the actor ideas, actor paradigm to the extreme and being fully, really working with no guarantees, working in this organic way, non-deterministic way, where we require a fair amount of testing, and each object is its own independent executable program, as it already is in some languages. So, as I said, but I think the final point that I think is that some people say that being forced to be distributed is going to be the death warrant of objects. Well, I think the opposite might happen. Being forced to be distributed might actually cause a resurgence in object thinking, perhaps not in name, but in substance. So in conclusion, first of all, we need to sort out the straw man. We talk about OOP, laws of attacks. They have no real basis in, well, they're fairly selective. We need to understand that when OOP became identified in the mind of people with Java or C++, that was a fairly drastic reduction of the original pool of ideas that were floating around and were called OOP. And a lot of these ideas are coming back now, are re-emerging now under different names, because it seems that the time has come when we actually need them. Original incorporates elements, as I said, of reactive actor system, publish, subscribe, and perhaps a tiny bit of functional as well. So in this sense, OP is alive and well under these different names. OP tends to rise naturally. I don't think we should fight it. Neither we should welcome. Neither we should reject additional expressivity that comes from other approaches when appropriate. But I don't think we should fight the natural tendency. So Java, as it is now, sort of what I call OP 1.0, might indeed perhaps be on its last legs in a sense. Now Java is evolving itself. It's adding features and adding various things. I don't know if it's managed to come to a sort of stable sense of identity yet about what it is, but to its credit, it's doing stuff about it. Well, the JVM as a platform, of course, it's not dead at all. It's doing very well. Design matters when we design things, and if we want to claim to actually do OOP, then we need to treat our objects with respect. Otherwise, we're doing something else that's probably not OOP. Complexity will always be there, and expecting something to reduce it drastically, automatically, in a new language or in a new paradigm might be perhaps a false problem when we're trying to solve difficult problems. In fact, I think with this idea of the magic solution is probably what ruined Agile partially, and I wouldn't want it to ruin other things that might come in up next. And again, this non-deterministic problem is something to think about. We're getting better at being deterministic about things, but I do believe that we're not, at one point we need to ask our own instinct to work for us when we reach a certain point when we cannot go by exact methods alone. And finally, We should be happy because if you think about it, we are at the cutting edge, if you will, of some philosophical research about the nature of problems and how we formulate and we solve problems. And these are very much fairly general, above the programming level, even more general than that. And we are sort of, I don't want to say the guinea pigs, but we are the researchers of those things, and I find it exciting of being at this sort of frontier. In closing, I hope you find it interesting. I really enjoy researching this talk, and I hope you have been able to take something away from it, despite all the talk. So thank you very much, and hope you enjoy the rest of the night.